but basically it's just using the tricks that we've already learned to do this problem here. There's really nothing new except the fact that now we're going to be actually deriving after we've integrated. Okay, so let's do this. Okay, so the secret to do this problem here is to always deal with whatever's inside the parentheses first, or the brackets first. In this instance, this is the integral of 0 to 3 x squared dx. Okay, so deal with this first. Do the integral of this, or the definite integral of this. Okay, so we know that this is just going to be x cubed over 3. Okay, and this is going to be from 0 to 3, and basically this is just going to be 3 cubed over 3 minus 0 cubed over 3. Okay, so when we do this, we see that it's just going to be 27 over 3, which is the same thing as 9, and this is just going to be 0. Okay, so we've got a value of 9 over here. Okay, so once you've gotten this value, right, what I want you to do, or what you should do, is now plug this value in to the parentheses you've got over here, or the brackets. Okay, so it's going to be dy dx of 9. Okay, so now if you look at this, all it's asking for is for you to find the derivative with respect of 2x of 9. In other words, all it's asking for you to do is find the derivative. So if I had to just, show you an arrow and show you what's happening here, go down there, it's basically saying f of x is equal to 9. Okay, find the derivative of f of x. So if we had to find the derivative of this, it's just going to be 0, and that would be your answer for this whole thing over here. It'll just equal to 0. Okay, so I know it may look overwhelming right now, but let's do another example. So let's say I've got dy of dx, right, of a function like, and they will usually do this because, if we always put numbers in our limits of integration, basically we're always going to come out with a 0 at the end of the day. Okay, so they'll usually do something like x and 2x, of the function x squared plus 2. Okay, let's say we've got a function like that. So what we're going to do is deal with what's inside first. Okay, so let's deal with what's inside first. So I've got the integral, right, of x that goes from x to 2x, x squared plus 2 dx. Okay, so when I take the integral of this, it's just going to be 1/2 1 cube x cubed plus 2x. Okay, this is going from x to 2x. So what's going to happen here is I'm going to be plugging in 2x for wherever I see an x. So it's going to be 1/3 2x cubed plus 2x minus 1/3 times x to the third power plus 2 times x. Okay, so what I've got over here is going to be basically 1/3 multiplied by, this is going to be 8x cubed plus 4x minus, and I'm going to just open the parentheses now, so this is just going to be minus 1/3 x cubed, right, plus 2, okay, minus, sorry about that, 2x. So let me just make this thing look pretty. I've got 8/3 x cubed plus 4x minus 1/3 x cubed minus 2x. Okay, And basically what's going to happen here is when I take the common terms, it's going to be 8 over 3 minus 1 over 3 is the same thing as 7 over 3 x to the third. So I can cancel those two. And that's just going to be plus 2x. Okay? So this is actually my value. So this is my value of what I'm going to plug in to here. Okay, so I'm going to be plugging that in this whole thing over here. So maybe let me just write it on the bottom. So I've got dy over dx of 7 over 3x cubed plus 2x. Okay, now that I got it there, basically all it's asking for me to do is to find the derivative of this function. So you can rewrite this if you want to as f of x equals 7 over 3x cubed plus 2x, and basically find the derivative of this, which isn't too hard. So it's f prime of x equal to, that's just going to be 21 over 3, or the same thing as 7, x squared plus 2, so that's just going to be 7x squared plus 2. And this is basically going to be your answer for this whole big problem here. Okay, or should I actually say for this whole big problem here, which is going to be what's it, 7x squared plus 2. So you can see it's not too difficult. So I'll catch you in the next video. Thank you for watching.